Alright, good morning. We are continuing with factoring expressions by grouping today. Yesterday we learned about common factors and picking the greatest common factor. Basically, you first break a number into its factors. Was 2, 3, and 5. 63 was 3, 3, and 7. You mark what's common on each side, and if there are more than one common items, you multiply them to find the greatest. But since this is single, you only take one and put it here. That's it. That's the greatest common factor. But for more complicated situations like this, you look at what's common between numbers, just like I did with 30 and 63, and it was 7 here. What's common between m squared and m cubed? It was m squared and n, and we all multiply these together. That's the GCF, greatest common factor. And we did find GCF of simple expressions yesterday, 2p plus 4, and the GCF among these was what's common between 2p and 4? It was 2. We separated out from this group. I put this example down. It's like recruiting a soldier from each family. You took 2 away from this family and p is left. I know it's a harsh example, but it stays in your mind. And you removed 2 from this 4, recruited him, and who's left is just 2. Okay, you just remove one of the 2's from the 4, and it's just 2 left, and this was the result. And today we're gonna do more GCF first, but in more terms, in more complicated expressions. This is our first one. Again, we are going to factor this expression completely later. The question here is not to factor out completely. It doesn't say factor completely. It just says factor out the GCF. So you need to first find the greatest common factor, GCF, on each terms, among each terms, and just pull it out. Recruit him and remove from 3 families here. There are 3 this time. So I will do this slowly for each one. There are 3 terms here: 5a squared, 10a, and 15. You see, I didn't take the signs in front of them. If you want, you can keep the signs here. This is negative, plus, but I ignore the signs. I don't deal with signs, okay? And I will break 5a squared into factors. Now number 5. What are the factors of 5? Just 5, right? 5 is a prime. I cannot split it more. A squared has double A. 10 is 2 and 5. I can break 10 as 2 and 5. But A is single. And 15 is 3 and 5 only. Correct? Now, what is common between in all 3 families, terms? All terms here, there is one thing common. Is it A's? Do you see A everywhere in each family? Do you? No. Is it 2? No. Is it 3? No. What is it then? 5. So there is only one thing common in all 3, which is 5. Most people think it's A, usually go with numbers, but no, A is not present on the last one. So we will only, when I'm factoring out this thing, that GCF will come here, okay? And you will take a parenthesis, and leftovers will be collected here. So what is that GCF we found? 5 only. And remove 5 from tax 5 to each and every family, or recruit 5 from everybody. If I take 5 away from a square, 5a square, what is left? If I remove 5 from 10, what is left? 2. Kinda this is gone, that's gone, it's 2a, but it's kinda negative. There is a negative 2a. And when I remove 5 from 15, what is left? 3. Since that's positive sign in front, I add 3. Okay? And later, not today, not now, later today, if we still have time, I will show you how to break this further, how to factor this into more factoring, but it's not required in this question. They just want this GCF out and you're done. But when I say factor completely, you're gonna break every long piece into smaller and smaller until it's not breakable. Okay? So what is the result then? This is what we are going to enter into our answer box. The expression is not prime. I found something, I pulled out something, so it's not prime. What is that thing you removed? It's 5 and 5a minus 2a and 3. Check. Nope, I made a mistake. Oh my god, it's too late now. So I was rushing, you see. And these are unfortunately single shot questions. I forgot to put a square here, 5a squared. So how can I get those missing credit? You just need to try another to get that credit. So you need to pay a price and restart a brand new question if you want to collect full credit. Okay? I'm not doing that. Okay. 7. Next question. You just have more and more stuff. That's it. That's the only difference here. Bigger numbers, more numbers, and more variables. But do we care? No, I will still take each family or term separately and break them as much as possible. Break each and search for something common. I know some people can skip this part and quickly say, oh, this is common between them, but I just want to make the secure way, okay? So how can I break 9? Break 9? 3, 3. And then M, how many M's we have? 4 M's. You don't have to break, but I still want to show details. And a single N. It's not breakable. N is not breakable. 12. How do we break 12? 3, 4. No, this is not complete factoring. There is more you can break 12 into. 12 is not just 3, 4. Yes, 3 is locked, but 4 is not locked. You can break 4 into another 2's. So it has 3 pieces. 2, 2, 3 is how you break 12. Okay? And how do you break M squared? It's double M and a single N. And last, 3 is not breakable, it's prime. 4 M's and 4 N's. Alright. Now simultaneously look at all 3 rows, expansions, 3 factors, 3 spots, and see, identify what number or variables are showing up in all 3 spots. First, do you see 2 everywhere? Starting with the smallest number here, 2. No, 2 is not present in the first one or third one. 3. Do you see 3 everywhere? I have 1, 3. That's common. Common factor, CF. Common factor. What else? M's. How many M's are matching? 2 M's matching. Another common factor then. N's. How many N's matching? Single. There are 3 common factors, but what is the GCF? Multiplication of all those 3 GCFs makes the greatest. Okay? So 3 M squared N. 3M squared N. multiply one row, 3m squared n, you're done. But we need to factor it out. 3m squared n from all three families, and leftovers will be collected in this parentheses. Now do this with visually here if you like. Remove 3 m squared and n. What is left on this one? You're just taxing each family. These guys, they are taken away from that family. So who's left in the family? 3m squared. Now I removed 3. I removed double m and n. What is left on this guy? Positive. Nope. 4. And in the last one, removed 3, removed m, one of the n's gone. What is left here? N cubed. Right? You kind of subtract these numbers. Look, there was 4, 2 away, there is 2 left. There was 4, 1 away. It's actually 1 here. There is 3 left. You subtract. Okay. Alright, this is it. Any questions? This is what you need to type in the answer box. Are we good? I'm going to the next one. Okay, now we're starting factoring things out. And here are the steps we need to follow. It looks like I forgot to copy the entire thing. Yeah, it's not saying factor yet here. It just says factor minus 2x. But how do I know I need to be factoring minus 2x here? But here is one fact I want to put here. We do not like negative in front of the leading term. This minus should be taken care of. We do not like seeing a minus, a polynomial starting with a minus. What do I mean by the leading term? I mean the term with the biggest exponent. Which one is it? Here. Okay? So it's 6x cubed, but I see a nasty negative. I need to take care of it. How? Just we need to factor out that minus sign from all three families. Like GCF removing, you're gonna remove that minus from everybody. You can't just remove from this guy. You need to be fair. You need to get the same tax from every neighborhood. Okay? So I'm going to take that minus out. But why do you think they also want me to take 2x? I understand why I'm taking minus. Why do you think they want us to remove 2x? Yeah, because 2x is the greatest common factor. Isn't 2 and x common most in all three spots? If you do that work, look, 6x cubed is 2 times 3 times x, x, x. 2x squared is 2x, x. 10x is, I'm leaving minus out. I'm not gonna write the minus here. So it is 2, 5x. Look what's common in each spot. 1x and 2's. So GCF is 2x. That's why they want us to factor it. So 2x, and we don't like the minus as well. With minus, they want us to take minus 2x out, okay? So let's see what's left. If you factor a minus from each and every term, you need to first flip the sign of each and every term. So this minus is gonna be plus, this second plus is gonna be minus, and the last one is gonna be plus as well. I just start with that one first. And all you need is, next is remove these guys. because they have been collected outside. I'm removing one x and I'm removing 2's and see what's left. What's left in each guy? What is it in the first one? 3x squared. Second one, only x. Last one is just 5. Again, we flipped these signs. Look, they flipped. Why did we flip them? Because we have taken a minus 2x out. I forgot GCF. It's minus 2x out, and these are the leftovers. I'm missing something. Oh, this is not 2, this is x, right? Again, 3x squared, x and 5, 3x squared, x and 5. How did I discover the signs? I just flipped the sign in front. When do I flip the sign? If you're removing a minus out. Why didn't we flip anything here? Because we didn't remove any minus. It was positive 3m squared. So we kept these signs as they are. 3 pluses, 1, 2, 3 pluses. Okay? Sign only changes if you're moving a minus out. So when I take minus 2x out, result is 3x squared plus, nope, it's minus x and plus 5. Okay. Now they want us to remove only 2x. They don't want to move the minus out. Okay, I will go with their request. What do you think? How do you think my answer is going to change? Since you're leaving minus 3 still in, the original signs will be preserved. No sign change required. So what is the original signs? Minus 6. So it's minus 3x squared then. So the answer from one above the same, except with the original signs from the expression. Yeah, it's hard to go in once you go out. Okay. Just use arrow keys once you mark some term, okay? So it is plus x and minus 5 then. It's just the opposite of these signs. Any questions? So you now figure out what happens if you move a minus out. It flips the sign, and we want the first term always. This is not the desired result. We want, for later purposes, factoring purposes, positive numbers are easy to manage. We like 3x squared better than minus 3x squared again. All right. Let me know if I'm too fast. Are we good? Okay, we're going forward with a new method, new technique. All right. Now, please, for a second, I would like to cover these for a second. And I'm going to ask you a simple question. What if you don't, these are disappeared, and instead they were just x's? What would you do? How would you factor this? Well, what is common between these two terms? 7x and t times x. What is common between 7x and tx? X, right? You would call these x's, this is your GCF. So you would call it out. And leftover items, once you tax each family, these guys, they are gone. So each family lost one member. So we have 7 and t left. Correct? Correct? Now, I'm clearing what I marked going back to original, this is what would you do. You would move these common items here. You would bring it in front, right? It's GCF and you bring in front. But these are not X anymore. They are R minus 6. But the important thing is, are these two as a block the same? Are they the same? Yes or no? Yes. Just like X, these two items are the same. So imagine this was X, I moved it here. Now they are R minus 6. So how am I going to modify this answer? X is gone. Instead you have R minus 6. I will put R minus 6. Since it's a block, they are not separable. One item, I need to keep them in parentheses. X was single, I didn't need a parentheses around it, but R minus 6 is together, so they need to be kept together with a parentheses. So this is it. This is how you factor out a GCF if common item is a binomial. So we need to understand what binomial means. Do you know the meaning of bi? Bi means like bi-weekly. That means two. So you expect two items. Okay? Binomials in loose definition means two-term expressions. Two-term expressions such as x plus 4 is a binomial. R minus 6 is a binomial. 5x plus 10 is a binomial. And you may say, wait a minute, how is this a binomial? This is three terms, right? Is it three? No, we don't treat 5 and x as a separate term. 5x as a block. If they are multiplying, two items are multiplying, they are kind of glued, welded together. They are glued together, so they are single item. So this is a single item, single term. We call it term, by the way. We don't use the word item, instead use term. So this is term, that's term. You have two terms, it's called binomial. Make sense? So when you see binomials, binomial here, you cannot remove them from this group separately. R and 6, they need to go together. Minus kind of makes a bond between them. It's bonded together. This is bonded together. They are not separable. Don't think you can take R out and leave 6 in. No, they're not separable. As a block, you need to cut them out with the scissors and move it away. That's the only way they go. Okay? Alright? So I see this mistake a lot. People see 6 and 6 matching. They only bring 6 out, leave R inside. Impossible. Plus and minus is a bond between these guys, and they can never be separated. You can separate 5 and x, like 5 times x. This is a loose bond. This is light, but this is strong. You cannot move this. 5 and x can be separated, but not x and 4, okay? Because look, if you have 5x and 10xy, you can separate 5 from this guy, right? Because it has 5 and 2. Multiplication is loose bond. You can make 5s go out, but not addition. Alright, so this is the explanation for this question. Anything, any issues? Anything unclear? Basically, you search what's common on those parentheses, take it out from those families or terms. Leftover items goes to the second spot. So it is R minus 6 is the GCF now. And once I remove them, what's left in that expression is nothing but 7 and T. Alright, we're going to the next one. Now, this procedure is extremely important. Okay. We are starting grouping, factoring by grouping method. And the remaining 4 questions 10, 11, 12, 13, 14, 13. 4 questions are about the same subject. I put 4 questions from the same subject because it's so important. We will keep doing this over and over in the next sections and even the next class. Trust me, I just did 11:50 in the morning this method. Pre-calculus class, upper level class. I did this method this morning because it pops up everywhere. Okay, so very important. When do we apply this method? This is called, it's called factoring by grouping, but factoring by grouping is most of the time applies to 4-term groups, 4-term expressions. You need to have 4 terms. You may say, I don't see 4 terms here. I see more than 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms, right? No. Do you recall my definition of term? I ignore multiplication, such as there is a multiplication here. So I ignore it and call this entire thing term. Here is 1 term. This is the 2nd term. And this is 3rd. And this is 4th. I see 4 term. Okay? Usually when I give you a sequence of terms, what you need to do first is, what did you do here in this question? When I give you a factor something, here for example, you break each term. This is 3 term, by the way, 1, 2, 3. You break each term and search for something common everywhere, correct? Correct? This is the thing you need to first try. Do you see anything common in all 4 terms? One item, either a number or letter, but popping up in each and every term. That's what we need to identify in step 1. Break everything in your mind or on paper. 10 is 25AA, 5AB, 8 is 222AC, 4 is 22BC. Any letter in all 4 terms common or any number. Take a moment. Yeah?
A.
A. I have 1A here, 1A here, 1A here. Where is the A on the last one?
I thought that before was an A.
Nope, sorry. A is not a common factor. Okay, good trial though. That's okay. More. How about B? Do you see B everywhere? C? No. How about 2? I have 2 in 8, 4 in, I have 2 in 4. I have 2 in 10. Do you have 2 in 5? Nope, I'm sorry. No G, C, F. There is nothing common. How can you expect to get the greatest of it, right? Impossible. Nothing common in this thing. It's dead. We can't pull anything out of it. It's like if you go, I gave this example the other time. If 2 people goes out to see a movie, you probably end up with a movie title you both enjoy, right? 2 people, right? Especially boyfriends or girlfriends, they agree on, but usually parents. No. Anyways, but if you go 3 or 4 people to see a movie, it's hard to come up with the same movie you will all enjoy, right? Okay, so it's the case here. There are 4 different personalities here, and there's nothing common about them. So what would you do? Unfortunately, you have 4 guys in the front door of a movie theater. 4 guys or 4 girls or group. But you don't agree on a movie title. What would you do naturally? Yeah. You're on the doorsteps of the movie theater, and there's an argument. Okay, you say, I don't want to go that movie. I say, I want to go this movie, and I have a friend who wants to go, he's okay with either movie. I mean, what would you do? Yeah?
I don't know.
Come on.
That's a tough question, man. Guess you just don't go to.
Now, one of your friends is really stubborn. I mean, he doesn't want to follow the other three guys. Or two guys. You want to, what I would do is, if really it's such a big deal, you would just separate into two people and go to one movie, and the other two go to the other movie, right? Right? Because you don't want to leave that guy out, because if three people goes to one movie, the other one is gonna be all alone and sad, right? So this is naturally, that's what we do in math. We try to pair up these guys and those guys, see if anything common between them. Let me pull it here. Do you see anything common between 10a squared and 5ab? And keep some space. This is a separate group now, these two guys. Do you see anything common among this group as well? So let me mark it. First two, last two split up on their own way. Anything common between 5a squared and 10a squared and 5ab? Let me break it into the simplest factors. 10 is 5 times 2a. This is 5ab already in simplest factors. Do you see anything common among these? Yeah. 5 and a. 5a. Both common, right? So can I factor these out? Here, GCF of these guys, only this group, GCF this group is 5a. If you tax each guy 5a, what is the leftovers items? What is left? 2a, right? And a minus in between, right? That's left. And what else? B. Okay? Now next, break each and every number in power. This is 4 times 2 is 8, right? But can I break 4 more? Yes, it's double 2. So this is triple 2. A and C. This is double 2. B and C. What is common between these guys? Double 2's. 4, in other words, 4 is common. So 4 is a great factor, common factor I can pull out. What else? And only C. So 4C, that means 4C is greatest common factor for this purple group only. So I'm going to pull that out as well. 4C out. I removed 4 and C from each guy. What is left on the first group? 2A. And how about this? 4C out. Who's left? What is the sign in between them? Alright, take a moment to think now. What did we do? Two groups, we separated two groups, 2 people in each, and they had something common between them, and we pulled that common things out, and we created some parentheses. But what do you see? Something significant on those groups now. I want you to refer back to this question. What did I do this question? And look at what I created here. What's that? These parentheses are the same. Look. Match. Just like earlier, these were matching. Now they are matching. Now what did I do earlier if they were matching? It's a GCF between those two groups. We removed it here. You're going to do the same thing. You will take this matching term out front here, like you're recruiting it, taxing those families, these guys. Once you tax them, they are gone from that family. This is gone. This is gone. And leftover items will be collected here. What is leftover? And what is left over here? And what is the sign? Mission accomplished. We factored it. Okay? Again, step 1 was finding GCF. We couldn't find anything. Step 2 is we did group first two terms together. First pair of terms, we found a GCF from them. We factored out that GCF from this pair of terms. And then we did it for the second half as well. GCF of the second group. And then in step 3, we found something common in those parentheses. If those two terms share a common binomial factor, this is binomial, two terms. Binomial means two terms. Then we factored out those binomials, and what's left is 4a, 5a, and 4c. This is how we do 4-term factorization. Okay? Let's do another one. It won't settle down until you solve 3-4 questions, okay? Okay, same deal. Step 1. I skipped step 1. I'm sure I won't find any GCF. I mean, do it anyways. Do you see anything common between all 4 terms? Anything in all overall 4 guys? They don't enjoy the same type of movie, right? I have 3s and 4s, but not everywhere. How about A, except the last one. I wish I had an A here. Now we would have something to call out, but no. Step 1, void. Step 2, I will group these 2 by 2. What's common between 3a squared and 3a? 1, 3 matching and 1a matching, right? 3a. What are the leftover items? If you tax 1a and 1, 3 to this guy, what is left? Only a. Plus you tax 1, 3, 1a. Oh, I have nothing left. That means it's 0. Agree? Do you agree? You trust me, right? Because I'm the authority here. I know more than you. Do you agree?
The 0 should be a 1.
Yeah, it's not 0. It feels natural, right? Once these guys wiped off, it must be 0 left. But no, every number multiplied, actually there is a secret number multiplying those 2 earlier. So if you see 2 numbers multiplying each other, there is actually a third number, stalker guy, creepy one following them. And what happens if you tax these guys, recruit these guys, take them away? That creepy guy is still there. One survives all the time. Okay? So every family has a ghost in their homes. That's 1. That's how you keep that in mind. Once you remove everybody, there is still a ghost 1 in there. How about here? 4a and 4. In this group, anything common? 4a and 4. Anything common? 4, double 2 is common, or 4 common. Once I tax 4 to each guy, what is left? A plus ghost, 1, right? Perfect. What is matching now? A plus 1, A plus 1. Move it here. Leftovers should be here. What is left out? These are gone. Just collect everything else beside these. 3a and 4. Okay, one mistake. I don't know intentional or just because of the excitement of the exam, but I see this. Since you are bringing two items out front, people put a square here because you have double items coming in front. But it's not actually double two items you're moving. Yeah, two items are gone, but they come always. You always take one sample of them, not two. You just copy it once, okay? Don't make a square here. It's just 1a plus 1 you borrowed from each. So this is the amount you're borrowing from each family. You're only getting one sample from each. Alright, any questions? Easy, right? So far? No? Let's take a look at this one. It's gonna get some challenging parts. This has a tricky part. Let's see if anyone can figure this. Or I'll give you a minute to finish this on your own. And tell me the result if you have one. See who's gonna be done first. Alright, first we pair up the first two, right? What is common between them? 3 and an x. So I tax a 3 and x to this guy, there is one x left. I tax 3 and x to this guy, only the ghost one left. Now what did you see common between these guys? What's common between minus 5x and minus 5? Oh, you pulled negative 5 out. You took not only 5 but also negatives as well. Okay. Then when I tax a negative and 5 to this guy, what's left is positive x here. When I take a negative and 5 both out, what's left is positive 1 here. And this way you found a match. I got it. It's a match. You pulled it out. And what's left over is leftover items are 3x and minus 5. 3x and minus 5. Perfect. Right answer. But I want to show you another option. If you're not this much careful, you may have a false, not false, but a different approach. So I'm going to back to this step. First step is the same. I agree with you here. This one has 3x common, so it's x plus 1. But one may say, why do we need to take negative 5 out? I want to take positive 5 out only. Positive 5. Look, do you see the sign? I didn't take minus, it's positive. If you remove only positive 5 from minus 5x like this, minus 5x, you're only borrowing positive 5, it's still minus x left here. And same way, if you remove positive 5 from minus 5, it's still negative ghost left. And this way, if you only take 5s out, digits, but not the minuses, are they a match? Are there a match here? No. So if in any time later in other questions or your own set, you're getting a mismatch, but the mismatch is only the signs are opposite. Look, these are positive, these are negative, then you know how to fix. Oh, I forgot the minuses then. Then go fix it by taking the proper minus out and make this positive. Okay? So you can make mistakes, but know what caused the mistake by comparing the results and signs. Okay? Got it? Now once I took the minus out, we will end up with the same answer. Alright, the last question, and this is the hardest one. There is a hint, but I covered it. No hint. Alright, I'll give you a minute to work on your own first. This one is tricky, right? Oh, you have one? Good, go for it.
Flip the,
Now, do you give me the final answer?
what?
Give me the...
I'll give you the final answer?
Okay.
Okay, give me that.
But you're right.
I thought you just wanted the trick.
You're good. The trick he gave us correct. We're gonna flip something. We're gonna replace some terms. Because sometimes the given order may not be the best order. So you may wanna switch those friends and pair up the right guys to go see that movie, okay? So we are gonna flip here. Anyone has the final answer? I just wanna see you can do it, yeah.
Parenthesis a plus b and then parenthesis y plus x.
Y plus x. Okay. Any more different answers? I know somebody got different answer, but you're too shy. No? You got the same thing? Okay. Alright. I will act like as if I didn't know this hint, and I will first try to pair up these two. But do you see anything common between a, y, b, x? Anything common? No. As well here, I don't see anything common. So I know there is something wrong going on here. That means the given order is not suitable for pairing up. We need to flip it. Flip in a way that at least one letter matches in the first two. So which terms you want to flip? First, second, third, fourth. Which two you want to flip? Reverse.
Flip the second and third.
Yep. Flip the location of these two. Okay? Or you can flip the first and last one. There are more than one way to do this, okay? There is no fixed way. You can flip the first and last, keep the second and third. But I will flip the middle terms. And we get AY, BY, BX, AX. And then, voila, what is common between these guys? It's Y. So I have A plus B left when I remove them. What is common here? X's, right? So when I call X out, it's B and A left. Right? Wait a second. I was expecting these two matching, but they're not. It's A plus B on the left and B plus A on the right. So they're not matching, right? Is that a match or not? They are the same. Although they are reverse order, A plus B and B plus A, they are a match. It's the same thing. So we can call these out as A plus B or B plus A, either way as you wish. And remaining terms are, once you move these, Y and X. Okay? Any questions? Alright. On Friday, we're going to start factoring completely. All the way, not factoring the GCF, but factoring to the very end, breaking all squares into single powers. Okay? That will be next.